Hello, I'd like to welcome everybody to today's webinar entitled Practical Enterprise Architecture for the Laboratory. Next slide, please. Before we get into today's session and introduce our guest speaker for the day, I'd like to briefly go over quickly a little bit about the company, Astrix Technology Group, why we think we have the right to be talking to you about these topics today. First and foremost, Astrix, from a company snapshot standpoint, is an informatics professional services and staffing company that's dedicated to serving specifically the scientific community. Some quick stats on Astrix. It was established in 1995. It's privately held. It had originated out of the IT division of a company called APBI, which at the time was a $300 million life science research organization. Today, Astrix operates from 8 offices throughout the United States and has greater than 500 employees. The headquarters is in Red Bank, New Jersey, and it has 2 very distinct divisions. First and foremost, a staffing division. This offers both private and public sector staffing within the scientific and IT resources communities. On a professional services side of the fence, it's focused on supporting science-based organizations with a variety of different practice areas, which we'll go into in just a moment. The target customer for Astrix is a Fortune 1000 life science enterprise, government, and research institutions with large and fast-growing IT, staffing, and compliance needs. The mission for Astrix has always been to deliver scalable, sustainable solutions in IT and staffing for the scientific community. Next slide, please. A little bit about the company foundation. At its core, Astrix helps clients excel and solve very complex problems with the right people and the right technologies. There's kind of 3 key elements to this. First is the science, in that Astrix has the capability to staff a project, IT or otherwise, with people with scientific backgrounds, practical bench experience, and very broad subject matter expertise. On the business side, there's laboratory management, laboratory operations, and managed services. And then finally, on the technology side, Astrix has a very specific focus on certain laboratory applications, LIMS, ELN, etc., as well as the ability to work within industry standard development and database tools. Next slide, please. Before we get into the presentation on today's topic, I'd like to introduce the speaker. Dave Dorsett joins us. Dave joins us with over 3 decades of experience in R&D informatics throughout the global pharmaceutical, chemical, and consumer good industries. He has a very extensive track record in architecting, designing, and delivering commercial and in-house informatics solutions across a very broad R&D spectrum, whether it's the early research stage or through the late stage development. Dave, I'd like to invite you to come on, and you're going to kind of take over the driver's seat, and I'll sit back and enjoy the presentation.
Okay, thank you. Thank you very much. Welcome everybody, and we'll get right into the subject here. What I'm hoping to give you some insight into today is sort of some of my views on, what enterprise architecture is as applied to laboratories, to the R&D process. Some aspects of what I think you should expect out of an architecture, the processes by which an architecture might actually be generated, and here and there maybe some insights into observations over my experience of positive aspects as well as some negative aspects of architecture and such. This is a very, very broad topic. So I've kind of put these slides together and this material together kind of as a high-level slice through the overall picture. Obviously, with respect to architecture, for a specific company and their business processes and their goals and the capabilities they're trying to build, there's a lot, more in-depth topics. We probably won't talk very much today. I won't talk very much today about sort of some of the technical aspects, if you will, of architecture, sort of, the pros and the cons of this technology, this approach, that approach. This is more about sort of the overall role of architecture in a project, and how and what architecture and architects can bring to a project, and what you might really expect out of them. So that's what I'm trying to accomplish today. Hopefully that's of interest to everyone, and you'll come out of this with some good understanding of what we're doing, what the possibilities are. So overall approach today, I kind of just touched on the subject matter a little bit. So I'm going to dissect basically the title of this into a couple different components. I'm going to talk about what, in my opinion, represents a practical architecture. So what does that actually mean? What is a practical architecture? What are the hallmarks of a practical architecture? We'll talk about that a little bit. Then we're going to talk about a little bit about enterprise level architecture as distinguished from, potentially other architectural aspects, and so a little bit about that aspect of the title of the talk today. And then finally, just a couple of quick thoughts on the laboratory specific side of this, as opposed to, sort of maybe more of the corporate systems world. In my career, I have actually spent most of my career in the R&D space, as was mentioned, from early development all the way into into technical transfer into manufacturing systems. I've also spent several years, about 5 years or so, in the corporate world, so in the corporate system side of things. So the final little bit will be a little bit about the laboratory aspects of this. And I want to encourage everybody to please ask questions. So this, like I said, this is a very, very broad topic. So I've sort of chosen here based on the title some aspects of what to cover, but I'm very interested in what specific people are looking for out of this. So I want to encourage everybody to ask questions. Okay, so practical. So let's start with the very basic fundamentals. Why do you need an architecture? The simple answer is you don't. And one of the analogies I'm going to use a lot in this, one analogy that a lot of architects actually use is in the in the construction industry. In the real world, lots and lots of things get built without an architecture. You put a shed in your backyard, you don't really invest a lot in architecture per se around that. However, if you're building a new house or a new office or redesigning an office park or things on those scales, those are the types of things where typically we see architecture in the real world. The buzzword phrase that architects like to use about things that get built without an architecture is we call the architecture emergent, which means it organically grows from answering or responding to the project or the program's needs and capabilities. So in some sense, everything winds up with an architecture at the end of it. I'm hoping in the course of this webinar to give you some examples of reasons why it's important, I think, to consider architectural aspects up front rather than simply letting them organically grow. But the reality is, real world, practical point of view, a lot of things get built without an architecture. And in fact, I have spent a fair amount of my time working with folks who are dealing with an emergent architecture, an organically constructed architecture, and really how to actually move that forward. And we'll touch on that a little bit as well. So I kind of already sort of preloaded a little bit of this. Does everything need an architecture? No. Simple answer. And it's tough to definitively produce some sort of a decision tree about when you need an architecture and an architect and versus when you don't. Like many things from a practical point of view in life, there's a big gray scale. There's clearly some things that don't and some things that do, and then there's a lot of questions in the middle. Some of the important characteristics, I think, of systems that really should have an architectural level of effort expended and thought process put into are clearly systems that are large, and that's kind of a vague word, but the characteristics of large that are important, I think, to being an architected system are a large user base. So something that's got to support thousands of simultaneous users, potentially even hundreds of simultaneous users, depending on the nature of the capability that you're trying to build. But a large user base is something that requires thought from an architectural point of view. Large amounts of data, so systems that are designed maybe for smaller users, but large amounts of data volume that are flowing through the system, or a large scope of business processes. So if you're building a capability that is meant to be used by everyone in R&D, as opposed to a particular team, then those are the kinds of systems I think that deserve architectural thought. Another aspect that's important architecturally, and I hope to come back with maybe some examples of this one, because this is a very common thing these days, is systems that are integrated. Integration between systems, even between COTS systems, is one of the more areas of criticality that I see today in working with folks. Doing integrations to meet business expectations as well as sort of availability and robustness expectations, and doing them in a supportable way is a very, very hot topic. And I think a lot of implementations, a lot of programs and projects can really benefit from having architectural guidance on best practices in that particular space, and really how to approach that with all the learnings that have come in our community and in the overall practice of IT, in fact. So integrations are a really key aspect. If you've got something you're building that's a standalone system for 10 people, architecture is not necessarily something to be concerned about. But 20 people with a heavy integration component to it, those are the kinds of things where I think some architectural thinking needs to be incorporated. Multi-process, multi-sites, are sort of obvious dimensions of large, potentially. Systems that are mission critical, where reliability and availability are very high priority to the business. That's another space where having an architect, investing in architectural thinking is critical to achieving those types of goals. And long-lived systems. This is kind of a tough one because sometimes we don't intend our systems to be long-lived. We build something and deploy a capability, and we think, well, this is a 5-year kind of thing that we built out. And turns into a 15-year or even beyond use. But systems that where we intentionally believe, from the business side that this is something that's going to have to be around for 10 years, and therefore has to have a level of flexibility, let's say, in it, to be able to be adaptable through that period of time with all the technological change that happens. That's definitely the kind of thing where you're going to want to have some architectural thinking actually. So does everything need an architecture? No. But these are the kinds of things that contribute to systems that really I believe need this kind of thinking. So, all right, continuing on with sort of our dissection of the webinar topic here. When I say practical architecture, I characterize myself as being a practical architect. And so what does that actually mean? So these are the kinds of things, the patterns that to me make up a practical architecture. So an architecture should contain actual decisions in it, right? There should be yeses and nos that are made in sort of a statement form as a result of the architecture. The architecture needs to say, we are doing this, we are not doing this. And by implication here, as I'm going through this, you can see that I have seen, experienced many architectures that don't meet these kind of criteria. So when I talk about a practical architecture, I talk about something that really has made decisions, that really describes a deliverable, real-world system. It's not, well, to be blunt, it's not slideware. It's not, box diagrams on a whiteboard. It is it's got actual decision to it. It describes something that is truly deliverable, truly real world. It has specifics within it that particularly address the risks within the overall program, or delivering the overall capabilities, the vision of what this project or program is about. Everything has risks. I believe that one key aspect of an architect and of an architecture is to really identify those risks, and as part of the design, part of the architecture itself, you need to be specifically speaking to those risks that need to be mitigated and the risks that are related to how you increase the probability of success for the program. So risk identification and risk, analysis, is to me a very important part of a practical architecture. And sort of along that way, you want the architecture and the architect to really be able to provide guidance for how obstacles are going to be overcome. the day-to-day reality of implementation of all systems, whether it's a relatively simple, let's say, COTS implementation that's got to be integrated with a couple of things, or if it's a very complex, homegrown, business process, kind of thing. The day in and day out is that, there are going to be obstacles that appear, despite everybody. If you have brilliant people doing the architecture and design, there's still going to be unanticipated things that arrive during the course of the project. And those obstacles, the architect should provide some guidance for how to get through those. What types of decisions are important, that would contribute to making those ongoing decisions. So it's the adaptation to change that's really, really important here. And that happens during implementation, and sometimes it happens after implementation as well. And I think it's important for an architecture to speak to as many of these things as it possibly can. Obviously, there are completely unexpected obstacles that appear as well, and you can't speak to what you don't know, but to the extent possible, practical architecture should really give long-term guidance for how a system should evolve. And again, another important component of a practical architecture is that it's not sort of predetermined. I mean, we'll talk in a little bit about how you go about, in my view, how you might go about doing this kind of thing. But there should be multiple approaches considered, and in an architecture document or in the process itself, there should be discussions about those multiple approaches and what the trade-offs are. There are very, very few things that are clearly sort of yes, no, black, white. And so there's always compromises involved. And it's very important from an architectural point of view that the candidates be identified with those kinds of trade-offs. Because actually, back to the earlier point around overcoming obstacles, sometimes in a project, the unanticipated obstacle appears, which changes the nature of the trade-offs in the candidate architectures. And the best thing to do is to actually revisit that discussion and say, well, we had considered doing it this way, and at the time the trade-offs kind of led us down this path, but things have changed now, and maybe we should reconsider an aspect of a different candidate approach. So I think these things are somewhat interrelated, and these are the kinds of things that I like to see, and the kinds of things that I like to try to contribute to projects from an architecture point of view. So because I have to put in the requisite number of buzzwords to discussions and such, we'll talk about anti-patterns. I guess it's a little out of favor now, but it was a big buzzword in maybe 5 years ago or so in sort of this field. So anti-patterns of a practical architecture, or what are impractical architectures? First of all, I've seen things called architectures, come across things called architectures, which are basically fully prescriptive. There's no discussion of trade-offs and risks, and it is do X, do Y, do Z. It's just a checklist. That to me is not really an architecture. That's a checklist. that's a project plan, right? That's not the kind of higher level sort of view to what are the different ways we could actually solve this problem, and what are the criteria that we would use to choose those ways. That's the kind of thing that I believe is an architectural level of discussion. Or the opposite of that, from an impractical architecture point of view, is one that's completely non-prescriptive. This is the PowerPoint and block diagrams on a whiteboard thing that I talked about before. I have seen lots of money spent on architectures for a program or at an enterprise level, and the actual deliverable was 100 slides in PowerPoint with basically very little content factor to that. That's not an architecture. Fully non-prescriptive, no decisions made, no real trade-offs identified, no risk, no discussion of risks. That's not a practical architecture. You can't do anything with that. No, similarly, or in a more detailed way, no discussion about implementation, right? It's not implementable. This thing, it describes something that is either motherhood and apple pie, so to speak. It's such a high level, nobody could disagree with it kind of thing, but is it real? Is it something that's actually, buildable? To go back to some of the building analogies, right? I mean, an architecture of a building by definition something that's constructible, right? It is a key aspect of a building architect, of construction architect skill set and deliverable, that this thing that they're designing to meet the requirements of the users and the owners of the building is something that actually can be built. You would never pay a construction architect to design a structure that wasn't engineerable. And I think the same is true in the software analogy. So really, it needs to be prescriptive enough and implementable. Nothing about risk. That's the opposite of what I was just talking about before. And nothing controversial. This is a little controversial statement, but I really believe that, in that discussion about alternatives and approaches to meeting your business needs and all that, that you're going to face moments in those discussions that are fundamentally controversial, not necessarily in a bad way, but decisions are going to have to be made, right? So you're going to have to decide the pros and the cons of a jointly. You decide the pros and the cons of a different approach, and nothing's going to be perfect. So there's a level, if architectures that I've seen, this kind of goes to some of these other points where it's all such a high level kind of thing, nobody can disagree with it. By definition, there's nothing controversial. There's no trade-offs that have ever been made. That's not an architecture to me. That may be a vision, okay? That may be some statement about, what we're trying to accomplish in 5 or 10 years, but that's not what I would characterize as a practical architecture. Okay. So that's that aspect of sort of the breakdown. So let's move on a little bit and talk about the phrase in the middle of the title, enterprise architecture. So what is an enterprise architecture as opposed to just some other kind of architecture? Other kinds of architectures might be program architectures, project architectures, integration architectures, etc. To me, enterprise architecture is not just about technology. Right? There are certainly clearly levels of architecture and design, as a process or as a goal breaks down, where technology is the critical aspect of it. But to be truly an enterprise architecture, it's really got to be something in the classic triad around people, process, and technology, right? So back to those candidates and candidates that you might consider for how to solve a business problem. It's not always about technology, and sometimes in the analysis and then the subsequent discussion about what approach to take, there are trade-offs, compromises that are being made around technology and process, for example. The system can only do so much, or this particular possibility, candidate architecture, can only do so much, but we can layer on top of that some process and people aspects in order to sort of reach the overall goal. Leaning, a stool that's too heavy, or where there's only one leg when it gets to that extreme, or when the legs are uneven, is not a comfortable place to sit. It's not going to be a comfortable, deliverable, of the vision and the capabilities. And so at the enterprise level, I really do believe that all these aspects of people and process and technology really should be considered. Simplicity is another important factor of enterprise architecture. I've seen a lot of recent blogs written, et cetera, around software complexity. And this has popped up multiple times over the years I've been doing. I've been in software business, but these days complexity is really we're battling incredible diversity of technology, incredible diversity of approaches, and the complexity of the systems that we deliver. In my mind, is really one of our key core struggles. I really, again, back to sort of balancing people, process, and technologies, I've seen things where the technology has simply just taken on too much, and that to meet the goals, the complexity level of what's been constructed is just frankly beyond something that I believe is going to be supportable or usable. We'll come back to that subject in a little bit. But complexity is something at the enterprise level, clearly at the large level, you really want to be sensitive to for enterprise architecture. When you get down into lower levels of architecture and design, in an integration, for example, there might be unavoidable levels of complexity because of the two parties that the two systems that you're attempting to integrate. But at the enterprise level, simplicity is a very important factor. You have to be aware of pushing the complexities around, right? So just opting out of confronting the problem, from a process or technology point of view, could easily shift the problem, just kick the problem down the road, essentially. You don't want to kick the problem down the road from the system that you're attempting to produce an architecture design for downwards into a different system. That's problem avoidance. It should be listed under the anti-patterns. But you really want to stand up to the questions and the problems and really put forward best case answers. I already mentioned integration as an important aspect of when I believe you need to consider architecture as being critical. At the enterprise level, integrations are today are some of our more critical aspects. That a lot of architecture effort and rightly so effort and expenditure, frankly, is done at the enterprise integration level. Bringing together manufacturing systems and late stage systems in developments, trying to bridge the gap between the research handoff into developments. These are high level integrations, and they're very, very critical. And a lot of the industry is extremely interested in optimizing those key aspects of integration. That's another example of clearly an integration problem that's not just a technology thing; it's a people and process thing as well. So, from a big scale, enterprise level scale, looking at, like how research hands off into pharmaceutical development or any development, chemical development, consumer goods, looking at those handoffs, it's unlikely that a pure technology solution is going to actually, deliver. There's got to be aspects of people and process brought to bear there. Okay, so moving on, a little bit more about enterprise. The biggest focus of most architectures that I have seen, or even done, frankly, in my career, is meeting the functional requirements, and that's justifiable. We're being tasked to implement capabilities to support a business, and those capabilities are functional requirements, right? So that is rightly the focus. But I think one of the things that I have certainly come to learn in my experience, both designing and architecting commercial software systems, and then actually running a big in-house shop for a decade, supporting those types of systems, is that the biggest issue after 5 years down the road, after that thing has been implemented, or maybe even 3 years or fewer years down the road, are the non-functional aspects. And these days, if there's one, this is kind of like my current hot button soapbox thing. The non-functional aspects of our systems do not get enough attention. And I really believe that it is the ultimate responsibility of an enterprise architect in an enterprise architecture to speak to and directly consider these non-functional aspects that are absolutely critical to the success post-go live. We in IT are very, very focused on the project, on the implementation, and boom, there's a go live, and we all declare victory and run away. But that's not reality, right? And the reality is that after that go live event, or after hypercare, that's the kind of popular phrase for the next month or so, couple months after an implementation, these are the kinds of things in the non-functional space that mean happy business people or unhappy business people. How incidents can be diagnosed, because the reality is everything we build in software has bugs, period. So you have to make sure that the system is adequately planned, that it can be supported when those incidents happen and the user calls the help desk or whatever the process is at the company. How is the system going to be diagnosed to be able to come up with what's wrong, what's the cause, and how fast it can, and therefore how fast it can be addressed? This is an absolutely critical aspect of systems, particularly mission critical systems, systems that are related to the bottom lines of companies, whether or not a product is released from a manufacturing process or not. The system's going to have issues, but it needs to be fixable. Those issues need to be identifiable rapidly. So enterprise architectures should absolutely be speaking to these administrative aspects. They should absolutely be speaking to the aspects of how the system is going to be updated, even minor updates. It should not cause large system outages. There should be explicit aspects of architecture and design that speak to how updates, even minor ones, are going to be handled. How's data migrated? How is regression going to be addressed? Those aspects. Obvious one, and I put it third because it is the obvious one: performance and reliability and scalability. Right? These are critical non-functional requirements. So you can have the best system in the world, makes the users when they're using it, they're absolutely in heaven. But if it's down, for a couple of hours, even when it's needed, the perception that the users or the scientists would have of your system is going to be severely damaged. It could be the best thing in the world when it's up, but if it's not reliable and it doesn't stay up, and if it's difficult to deploy to another site and add more people to the system and do those things, it is not going to be a successful system. And I spoke to this a little bit earlier when I talked about one of the characteristics of systems that need architectural thinking being longevity, but even not necessarily in a time sense, but longevity with respect to the business. If the business is going to be undergoing M&As and divestitures and things along those kinds of lines, flexibility of the system is going to be ultimately for success a very important non-functional characteristic. You've got to be able to manage the data lifecycle with respect to business events. This is another thing I've seen a considerably less thinking about than I would I would like to see, which is the data lifecycle. So what happens when the company has to divest a unit? Is the data actually extractable from the system in such a way to meet the business requirements? What happens with M&As? That's the reality of the business world that we live in. The system architecture and the system design needs to speak to that. Data archival. I've seen way too little thinking about the archival and retirement of systems and how data will be moved, into appropriate places to meet records management requirements. So those are the kinds of non-functional aspects that I really believe that I see non-sufficient thinking at the enterprise level. Now, not all of these things are important when you're talking about architecture at maybe a low-level kind of project level or specific aspect of a project. But to be an enterprise architecture means, to me, you have to be looking beyond the implementation. The enterprise architecture should speak to these very critical, high-level, non-functional aspects of the system. And it should lay out those yeses and nos. The system will handle data this way in order to meet these non-functional aspects around data lifecycle. Retrieval and archival, and divestiture, M&A, archival, the things I was just speaking of. The enterprise architecture should speak around the boundary conditions that all the components of the system are meant, have to abide by in order to be, have system incidents being diagnosable. So this was a little bit of the thinking here around what it meant to be the enterprise architecture. On top of being practical. So we're developing a fairly long list here of things that you really want to see in an architecture. And I think it should be becoming pretty obvious about why just sort of the classic architect's whiteboard full of black boxes and high-level conceptual statements don't meet the definition of what I truly consider architectures. These are all very, very specific things we're talking about. So a little bit now about the laboratory aspect. As I mentioned, most of my career has been in the R&D space. I guess the simplest way to describe those in and around the laboratories. I was trained as a chemist, so I still love actually walking around the labs themselves and seeing what people are really doing, and believe that's an important component of things. And that's really, it's putting the scientists first. Those are our customers. And the architecture must embrace the science to be a true laboratory architecture. architecture, and that means we brace the unexpected, right? Trite saying, but still true. If we knew what we were doing, it wouldn't be research. And so that trickles into the systems as well. Part of that's flexibility. So I spoke to a little bit before around big events like M&As and divestitures and all that, but there's a degree of flexibility in laboratory systems architecture that has to address this. Laboratories are just full of change. There's lots of planned changes and there's unplanned changes. And the design of, the architecture and design of the data management and the architecture and design of the user interface and the way the business processes are managed has to have sufficient flexibility to it to be able to meet the changing dynamics of laboratories. And that is, I've seen a number of places where comes out the user interface has got very, very sort of fairly rigid expectations of the user goes from process A to process B to process C to process D. Well, okay, that may be 80% of what that scientist is doing today in their labs, but then instrumentation changes and now it's A, C, D, B, and the system is completely unable to handle the fact that you're doing your data management, your data gathering and analytics and those kinds of things in a different order now, because one important component of the system, your analytical instrumentation, now is doing things that in a different way. And so embracing changes and flexibility is a very critical part. Now, you can go overboard with this too. I've seen systems that are so flexible, have been deliberately designed to be so flexible and so changeable that they become, frankly, difficult to administer. Back to some of those non-functional requirements. They become difficult to upgrade because they have so many aspects of change to them that the change management of the system is just unbearable. And that gets particularly bad with architectures and designs where the configuration itself is kind of locked away in the product, right? It's in some proprietary file format somewhere that you can't read and you can't document, or it's scattered across multiple different pieces of the administrative user interface to do the configuration, and then the configuration data is written, half of it's written in a database and other pieces are in files, and so when systems that are designed deliberately to be highly flexible take a scattered approach to their architecture, you wind up missing that non-functional requirement around the ability to update and upgrade systems. And so delivering flexibility to meet laboratory needs is really, there are costs to it. These trade-offs are a part of any R&D IT architecture. You really need, there may be levels of flexibility that you can decide you don't need, right? And that's part of the candidate and the trade-off discussion that I was talking about earlier. So that was sort of the segment of this about, sort of breaking down the title of this. And again, this is such a broad topic, and I'm hoping that people have questions about, about all of these aspects of things. But we'll move on a little bit and talk about, again, how do you practically do a practical architecture? How do you start? How do you get this off the ground? So step one, find a good architect. And this in itself is a whole discussion. What are the characteristics of a good architect? But for now, let's move on to hearing a little bit, talking a little bit about what the overall process is. You want the architect, you want an immersion in the business processes. There was a webinar last month. Randy Heiss gave a webinar on business process analysis. And that's the type of input that you want to provide to your architect. You want them truly immersed in understanding what the future state of the business processes that they're going to need to be producing a system architecture for. So they've got to embed this in themselves. They've got to swim it. They've got to believe it. They've got to live it to understand how to construct a solution that's going to deliver those capabilities. Then you begin, then generally speaking, like to lay out the constraints. And constraints can be technical constraints, like it's got to be, it's got to be a cloud-based thing. It can be a financial constraint. It can be a time constraint. It's got to be delivered. First phase got to be delivered in a year, right? Those are fun ones. So everything has constraints. So it's important to get those on the table quickly as well, because they will drive a lot of the decision making. Identify uncertainties. There are going to be parts of the future business process, or maybe the constraints, that have levels. All of it should have levels of uncertainty. Some of it might be, well, it's unlikely to change. Some of it might be, well, it's highly likely that in the scope of this capability that we're architecting, the company will be merging with another company or buying another company. That's a very important thing to get out on the table in the enterprise architecture. So identifying the uncertainties and identifying the probabilities associated with those. Technology goals. These are things like, I want it to be cloud-based. Potentially goals, around some of the other technical, sides of things. It needs to be accessible to our partners through a web portal. These capabilities need to be, fully web-based, mobile accessible, those types of things. Not answers, but goals, right? Not solutions, but the goals aspect of that. And then the final point is partially back up to what Randy covered in the business process analysis. That's the current state and starting point. And my personal process and my recommendation is that you hold off on that until you get all this future laid out, right? You really want to fully understand and be immersed in where you're trying to go. And then it is very important to understand what the current state and the starting point is. But after you've immersed yourself in the future. So a little bit about what should the outcome of this, what should this architecture look like? Some of that you heard earlier when I was talking about the characteristics of a practical versus an impractical architecture. But to put a little bit more on that, what should you expect from your architect release? So you should expect a deliverable, which the only way I can describe this is sort of by analogy. If you were going to take a month-long excursion to somewhere you've never been before, you were just going to drop everything and drop yourself into a completely place you've always been interested in, might know a little bit about, but you're going to spend a month there just embedding yourself into it. So what are you going to want to have, right? What are you going to want to prepare? You're going to want maps. You're going to want dictionaries. You're going to want some information about do's and don'ts culturally, those types of things, right? You're going to want to understand, what are the boundary conditions, where are my directions, what are the major sorts of things. But it's unlikely, at least, from an architectural point of view, you can't totally plan out everything that's going to happen in that month. That's why I chose a month-long trip as opposed to a 2-day trip. So if it's going to be a month-long trip, it's got to be an agile sort of set of stuff you've got to prepare, right? Can't be overly prescriptive because stuff's going to change. And you got to be prepared for that. So your maps you're going to have maps at high levels and surrounding levels, right? In order for that to be useful. Shouldn't really be overly prescriptive because it's probably going to go belly up after about 3 days, right? The first plane you miss, the first train you miss, then you're completely off. You don't want to necessarily, at least for me, and maybe it's a personal thing, but you don't want to make all the decisions, right? I want the bigger picture of what I'm trying to do, but I'm not going to plan every footstep I'm going to take to every site, all that. I'm going to want to leave open the possibility that I want to react to something. And that actually is the core of what agile, I use the word agile here. To me, this is a whole other discussion, but the core of being an agile architecture or an agile anything actually is leaving open the possibility for things to happen that you don't know, right? You're going to leave open those opportunities and things. So you want your architecture to keep the bigger picture in mind, and that's what I mean by being agile. Talked a little bit about that before in other ways as well. So I think, threw out a couple examples in there around sort of the technology sides of things. I did say at the early part of this is not really a design webinar about like how to use, multi-tier architectures and cloud-based service mashups and, database technologies like NoSQL versus relational and all those kinds of things. This is really about that building that high-level picture, but a little bit about technology. One common slipping place that I see in with respect to enterprise architectures is not enough analysis on the risk side of things and then the contingency side of things about the limitations of the technical architecture of the system. This is something that happens in COTS implementations. All COTS implementations carry their own architectures, their own designs. They all have trade-offs. There's no such thing as the system that will do it all, despite what any vendor will tell you. And pushing a system beyond those fundamental assumptions of its architecture and design is a significant root cause of projects gone bad. So even in a COTS implementation, let's call it a straightforward project, it's important from an architectural point of view to work to understand what that technical architecture is, what those limitations are going to be, and how does that match up with the goals that you're trying to accomplish, or how are you going to mitigate that, either in your own infrastructure or other systems around it, or taking alternative approaches to the way it's deployed, or what have you. So, from a technology point of view, understanding those technical architectures is an important exercise with COTS implementations from an architectural point of view. Another important tip around the technology is that, technology design and at the level of architecture design, you might hear people come and talk about, well, gee, it's a pipeline, approach. We get this really cool approach to how we manage data movement and data integration, and it's based on a pipeline and blah, blah, blah. All those patterns of design that people like to talk about, or technical architects like to talk about, layers and pipes, for example, they all include or imply certain behaviors as well. And this is, I guess, part of the limitations of the technical architecture. They might have side effects. They might have, side effects. You might, wind up with a pattern design that might simplify the administration of a system, but wind up giving you problems when you actually try to scale that system up and have a bunch of people join the user community. And these kinds of technology aspects that I've been sort of talking about here around understanding limitations and really reflecting that in your enterprise architecture for implementation of things is really important for integrations. Again, this is, we have a lot of very tried and true, and by that I mean architectural approaches to doing integrations that go back into the 50s and the 60s. The very first computer airline reservation systems developed patterns of integrations that, from my point of view, I don't see them frequently enough applied. I see just sort of lack of a sense of history, if you will, in this arena, in IT, in software engineering. There are really good lessons to be learned frankly, from systems that are still running today and were architected and built 40 years ago, 30 years ago. There's a reason why those systems are still running today. And as an architect, as a long-term software engineer, those lessons and learning that history, I happen to be a history buff in general, but as applied to this discipline, I really think that there are aspects of these things that are tried and true approaches to things that are just far too infrequently used from a technology architecture point of view. Okay, so that's pretty much what I put together today. Like I said, this is kind of a 30,000-foot flight through the through the topics through this practical enterprise architecture for the laboratory. I hope you found it interesting, hopefully somewhat thought-provoking, and with that, I think we'll see if we have questions.
We don't have any active questions right now, so we can certainly, if anybody wants to submit them now, you're welcome to do that. If not, then you can always, of course, email those questions in if you so choose. We'll go ahead and stop the recording.